Okay, so what we want is just to see what the graphics of sin x means. So now we have the sin function. I use the modulus because what we need next is to modify the radius of the circle using a trigonometric function. So we'll go back to a circle of radius r, and then I'll replace r with a function of t. And now all we have to do is to modify the numbers of petals. So we have to create first a function which has just one petal. So I'll divide it by 2. So now we can have a full control of the number of the petals. So I'll multiply it with a natural number. Okay, we obtained our flower. For math teachers, I mentioned that we can also study the frequency. Let's say n is not a natural number from the beginning, so now is more intuitive what is happening. We can also modify the amplitude and so on. We can study, let's make it positive. After we have the basic flower, we can make it more complicated, like we can add to this simple shape another function. I'll go back to one petal and then I'll make the addition of those, and we can also modify the amplitude of the second one. So what we have now is the form of one petal, which is more complicated than first. And let's say this addition is another function. Let's call it h. So now we can replace the radius with h function, but we can also need to modify its frequency. So we can modify it right here, or we can also modify it from the beginning, because in programming it's better to have just a simple instruction, just one function we need. So I replace f and g with their expressions, and I'll multiply here with n, and now we can see that we can control the number of the petals. We see the petal as just one object, so we don't have to think of those two functions individually. This concept I'll show you in a more complex form to understand why is this important. I show you the concept in my PhD thesis,